So, let's talk about statistics. I know, the word itself can sound a little intimidating, right? But it's really just a tool we all run into every day, from the news we read to the ads we see. It's the science of making sense of data, and in this explainer, we're going to show you how to use it to get a much clearer picture of the world.
You've probably heard the saying, numbers don't lie. But is that really true? The thing is, they can be used to tell a very, very misleading story. Have you ever looked at a statistic and just had that gut feeling that something was off? If so, you are definitely not alone.
In fact, there's a pretty famous phrase for that exact feeling. It perfectly captures that common suspicion that statistics can be twisted and turned to support just about any argument someone wants to make.
Yeah, this one. There are three kinds of lies: lies, damned lies, and statistics. Mark Twain famously quoted the British Prime Minister Benjamin Disraeli with this line: "It's such a powerful reminder to be a critical consumer of data." So let's look at a couple of examples where this kind of healthy skepticism is a really good idea.
Okay, so picture this. You see a claim from a marketing team. A new ad campaign launches and bam, sales shoot up 30% over the next 3 months. Your first thought is, wow, that ad must have been a huge success, right? Well, maybe, but maybe not.
Or how about this one? This one's a little more interesting. If you actually look at the data from various cities, you'll find a strong connection, a correlation between the number of churches and the number of crimes. The more churches a city has, the more crime it has. So, does this mean that churches are somehow causing crime?
Now, here's where it gets really tricky. The numbers behind both of those claims, they're technically correct. The sales did go up, and there is a correlation between churches and crime, but the conclusions drawn from them are completely flawed. The key isn't just about the numbers themselves, it's about understanding how they're being used, and we're about to give you the toolkit to see right through these kinds of deceptions.
All right, so our first tool is understanding that statistics really comes in two main flavors. And this is a really fundamental split that completely changes what we can and can't say about the data we're looking at. So on one side, you've got descriptive statistics. The easiest way to think about this is just the facts. It's all about organizing and summarizing the data you actually have right in front of you. What you see is what you get. Then, on the other side, you've got inferential statistics. This is more like the educated guess. This is where we take data from a small group and try to draw smart conclusions about a much, much larger one. And this table right here, it's a perfect example of descriptive statistics. We're looking at average salaries for different jobs way back in 1999. It's not guessing, it's not predicting anything, it's simply describing the data that was collected. We can see very clearly that pediatricians, on average, earn significantly more than police officers. That's a description, not an inference.
But here's the thing. Most of the time, we can't get data on everybody. That's where that educated guess of inferential statistics comes into play. And to really get that, we first need to understand the difference between the whole big group and just one little part of it.
In the world of statistics, the population is the entire group we're interested in studying. We're talking all American adults, or every single student at a university, or all the cars made by one factory. It's the whole enchilada.
But I mean, trying to study the entire population is often just impossible or crazy expensive. So what do? We take a sample, a small, manageable slice of that bigger population. The whole idea is that if you choose your sample the right way, it's going to represent the entire group. It's kind of like tasting one spoonful of soup to figure out what the whole pot tastes like.
And here is where things can go really wrong. What if that spoonful you took was all broth and no noodles, or all noodles and no broth? If your sample doesn't accurately reflect the population, then any conclusion you make about the whole pot is going to be, well, wrong. This is what we call sampling bias.
So yeah, avoiding a biased sample is absolutely crucial. Think about it. If a teacher only asks the 10 students sitting in the front row about test scores, well, those are probably the most engaged students, right? Their scores are likely higher. Or if a coach asks for volunteers to do cartwheels, you're only going to get the kids who are pretty sure they can actually do one. And just surveying people whose last name starts with Z, that might seem random, but it isn't representative. None of these samples can tell you about the whole population.
Okay, so now we have our basic tools, right? We know about descriptive versus inferential statistics and population versus sample. So let's go back to those tricky claims from the beginning and see if we can spot the traps.
All right, let's revisit that churches cause crime idea. The flaw here is a classic statistical trap called the third variable problem. See, it's not that one thing is causing the other. It's that a hidden third thing is causing both. In this case, it's simply the size of the city. Bigger cities have more people, and more people means more of, well, everything. More churches, more schools, more grocery stores, and yeah, more crime. This is probably the single most important rule in all of statistics. Correlation does not equal causation. Just because two things happen together doesn't mean one caused the other.
And what about that ice cream ad? Remember, the ad ran in June, July, and August. What else happens in those months? It gets hot, and people eat more ice cream. This is a classic history effect. The sales increase probably had very little to do with the ad and everything to do with the season. Without comparing those sales to sales from the previous summer, that 30% increase is a pretty meaningless statistic.
So, what does this all mean for you? It means you now have a new superpower, statistical literacy. It's the ability to look past the flashy headlines and really question the numbers you see every single day.
And the best part is, you don't need to be a math whiz to do it. The most important skill is just critical thinking. It's about asking questions like, who was sampled for this poll? How was the data collected? Is there another variable, like the weather, that could explain this? That's the real core of being statistically literate.
Okay, let's test out this new superpower with one last example. A report claims a university's athletes have SAT scores 20% lower than non-athletes. Now, on the surface, that sounds pretty significant. But is it a valid comparison?
It's actually super misleading. Think about it like this. Is 20 degrees Celsius twice as hot as 10 degrees? No, of course not. That's because the scale doesn't start at a true 0 point of no heat. The SAT is similar. The scale starts at 400, not a true 0. And because of that, you can't say something is 20% lower. A score of 800 isn't twice as good as 400. It's a classic trap of applying the wrong kind of math to this type of scale.
So the next time you see a statistic, a poll, or a percentage, don't just accept it. Take a moment, ask the right questions. What other numbers you encounter every day, in ads, in news reports, in work presentations, might be telling a slightly different story than the one on the surface.